So you, Dylan, collect a lot of information about each of the mega clusters for each of the major AI companies. Can you talk about the build outs for each one that stand out?
Yeah, so I think the thing that's like really important about these mega cluster buildouts is they're completely unprecedented in scale, right? US, sort of like data center power consumption has been slowly on the rise and it's gone up to 2-3% even through the cloud computing revolution, right? Data center consumption as a percentage of total US. And that's been over decades, right, of data centers, et cetera. It's been climbing slowly. But now 2 to 3%. Now by the end of this decade, it's like even under like, when I say like 10%, a lot of people that are traditionally by like 2028, 2030, people traditionally traditional data center people like that's nuts. But then like people who are in like AI who have like really looked at this at like the Anthropics and OpenAIs are like that's not enough. And I'm like, okay. But like this is both through globally distributed or distributed throughout the U.S. as well as like centralized clusters, right? The distributed throughout the U.S. is exciting and it's the bulk of it, right? Like, hey, OpenAI or say Meta is adding a gigawatt, right? But most of it is distributed through the U.S. for inference and all these other things, right?
So maybe we should lay out what a cluster is. So, does this include AWS? Maybe it's good to talk about the different kinds of clusters and what you mean by mega clusters and what's a GPU and what's a computer and what is getting not that far back, but yeah. So like, what do we mean by the clusters and the build outs?
I thought I was about to do the Apple ad, right? What's a computer? So traditionally, data centers and data center tasks have been a distributed systems problem that is capable of being spread very far and widely, right? I.e., I send a request to Google, it gets routed to a data center somewhat close to me. It does whatever search ranking recommendation, sends a result back, right? The nature of the task is changing rapidly in that there's two tasks that people are really focused on now, right? It's not database access. It's not serve me the right page, serve me the right ad. It's now inference, and inference is dramatically different from traditional distributed systems, but it looks a lot more similar. And then there's training, right? The inference side is still like, hey, I'm going to put thousands of GPUs in blocks all around these data centers. I'm going to run models on them. User submits a request, gets kicked off, or hey, my service. They submit a request to my service, right? They're on Word and they're like, oh yeah, help me Copilot, and it kicks it off. Or I'm on my Windows, Copilot, whatever, Apple Intelligence, whatever it is, it gets kicked off to a data center, right? And that data center does some work and sends it back. That's inference. That is going to be the bulk of compute, but then that's like, there's thousands of data centers that we're tracking with like satellites and like all these other things. And those are the bulk of what's being built. But the scale of, and so that's like what's really reshaping and that's what's getting millions of GPUs. But the scale of the largest cluster is also really important, right? When we look back at history, right, like, or through the age of AI, right, like it was a really big deal when they did AlexNet on, I think, 2 GPUs or 4 GPUs. I don't remember. It was a really big deal.
It's a big deal because you use GPUs.
It's a big deal they use GPUs, and they used multiple, right? But then over time, its scale has just been compounding, right? And so when you skip forward to GPT-3, then GPT-4, 20,000 A100 GPUs, unprecedented run, right? In terms of the size and the cost, right? A couple $100 million on a YOLO, right? A YOLO run for GPT-4. And it yielded, this magical improvement that was like perfectly in line with what was experimented and just like a log scale, right?
Oh yeah, they have that plot from the paper. The technical report.
The scaling laws were perfect, right? But that's not a crazy number, right? 20,000 A100s, roughly each GPU is consuming 400 watts. And then when you add in the whole server, right, everything, it's like 15 to 20 megawatts of power, right? Maybe you could look up what the power of consumption of a person is because the numbers are going to get silly. But like that 15 to 20 megawatts was standard data center size. It was just unprecedented. That was all GPUs running one task.
How many watts was a toaster?
Yeah, so a toaster is like
that's a good example.
A similar power consumption to an A100, right? H100 comes around, they increase the power from like 400 to 700 watts, and that's just per GPU, and then there's all the associated stuff around it. So once you count all that, it's roughly like 1,200 to 1,400 watts for everything, networking, CPUs, memory, blah, blah, blah.
So we should also say, what's required? You said power, so a lot of power is required, a lot of heat is generated, so cooling is required. and because there's a lot of GPUs that have to be, or CPUs or whatever, they have to be connected. So there's a lot of networking.
Yeah,
Right.
so I think, sorry for skipping past that. And then the data center itself is like complicated, right? But these are still standardized data centers for GPT-4 scale, right? Now we step forward to sort of what is the scale of clusters that people have built last year, right? And it ranges widely, right? It ranges from like, hey, these are standard data centers and we're just using multiple of them and connecting them together really with a ton of fiber between them, a lot of networking, et cetera. That's what OpenAI and Microsoft did in Arizona, right? And so they have 100,000 GPUs, right? Meta, similar thing. They took their standard existing data center design, and it looks like an H, and they connected multiple of them together. And they first did 16,000 GPUs, 24,000 GPUs total. Only 16,000 of them were running on the training run because GPUs are very unreliable, so they need to have spares to like swap in and out. All the way to like now 100,000 GPUs that they're training on Llama 4 on currently, right? Like 128,000 or so, right? This is, think about 100,000 GPUs with roughly 1,400 watts a piece. That's 140 megawatts, 150 megawatts, right? For 128,000, right? So you're talking about you've jumped from 15 to 20 megawatts to 10x, almost 10x that number, 9x that number to 150 megawatts in 2 years, right? From 2022 to 2024, right? And some people like Elon, that he admittedly, right, and he says it himself, got into the game a little bit late for pre-training large language models, right? xAI was started later, right? But then he bet heaven and hell to get his data center up and get the largest cluster in the world, right? Which is 200,000 GPUs. And he did that. He bought a factory in Memphis. He's upgrading the substation, but at the same time, he's got a bunch of mobile power generation, a bunch of single cycle combine. He tapped the natural gas line that's right next to the factory and is just pulling a ton of gas, burning gas. He's generating all this power. He's in a factory, in an old appliance factory that's shut down and moved to China long ago, right? Like, and he's got 200,000 GPUs in it. And now what's the next scale, right? Like all the hyperscalers have done this. Now the next scale is something that's even bigger, right? And so, Elon, just to stick on the topic, he's building his own natural gas plant, like a proper one right next door. He's deploying tons of Tesla Megapack batteries to make the power more smooth and all sorts of other things. He's got like industrial chillers to cool the water down because he's water cooling the chips. So all these crazy things to get the clusters bigger and bigger. But when you look at, like, say, what OpenAI did with Stargate, that's that in Arizona, in Abilene, Texas, right? What they've announced, at least, right? It's not built, right? Elon says they don't have the money. There's some debates about this. But at full scale, at least the first section is like definitely money's accounted for, but there's multiple sections. But full scale, that data center is going to be 2.2 gigawatts, right? 2,200 megawatts of power in, and roughly like 1.8 gigawatts or 1,800 1,800 megawatts of power delivered to chips, right? Now, this is an absurd scale. 2.2 gigawatts is like more than most cities, right? To be clear, and it delivered to a single cluster that's connected to do training, right? To train these models, to do both the pre-training, the post-training, all of this stuff, right?
This is insane.
It is. What is a nuclear power plant
and
again?
Everyone is doing this, right? Everyone is doing this, right? Meta in Louisiana, right? They're building 2 natural gas plants, massive ones, and then they're building this massive data center. Amazon has like plans for this scale. Google has plans for this scale. xAI has plans for this scale, right? Like all of these, the guys that are racing, the companies that are racing hard, and they're doing multi-gigawatt data centers, right? To build this out because they think that if I now have obviously pre-training scaling is going to continue, but to some extent, but then also all this post-training stuff where you have a RL sandbox for computer use or whatever, right? Like this is where they're going to, and all these viable domains where they just keep learning and learning and learning, self-play, whatever it is, makes the AI so much more capable because the line does go up, right? As you throw more compute, you get more performance. The shirt is about scaling laws. To some extent, it is diminishing returns, right? You 10x the compute, you don't get 10x better model, right? You get a diminishing returns, but also you get efficiency improvements, so you bend the curve, right? And these scale of data centers are doing, wreaking, a lot of like havoc on the network, right? And Nathan was mentioning there's Amazon has tried to buy this nuclear power plant, Talon, and if you look at the Talon stock, it's just like skyrocketing, and they're building a massive multi-gigawatt data center there. And, you just go down the list. There's so many ramifications. Interesting thing is like certain regions of the US, transmitting power cost more than actually generating it, right? Because the grid is so slow to build, and the demand for power and the ability to build power and like re-ramping on a natural gas plant or even a coal plant is like easy enough to do, but like transmitting the power is really hard. So in some parts of the US, like in Virginia, it costs more to transmit power than it costs to generate it, which is like, there's all sorts of like second order effects that are insane here.
Can the power grid support this kind of growth?
Trump's executive orders, there was a Biden executive order before the end of the year, but then Trump had some more executive orders, which hopefully reduce the regulations to where, yes, things can be built. But yeah, this is a big challenge, right? Is building enough power fast enough.
Are you going to basically have a nuclear power plant next to a data center for each one of these?
So the fun thing here is this is too slow.
To build the power plant.
To build a power plant or to reconfigure an existing power plant is too slow. And so therefore you must use data center power consumption is flat, right? It's spiky,
which is
right?
why nuclear is also good for it. Like long term, nuclear is a very natural fit, but you can't do solar or anything in the short term like that.
Because data center power is like this, right? Like you're telling me, I'm gonna buy tens of billions of dollars of GPUs and idle them because the power's not being generated. Like power is cheap, right? Like if you look at the cost of a cluster, less than 20% of it is power, right? Most of it is the capital cost and depreciation of the GPUs, right? And so it's like, well, screw it. I'll just I'll just build natural gas plants. This is what Meta's doing in Louisiana. This is what OpenAI is doing in Texas and like all these different places. They may not be doing it directly, but they are partnered with someone. And so there is a couple hopes, right? Like one is, and Elon, what he's doing in Memphis is like, to the extreme. They're not just using dual combined cycle gas, which is like super efficient. He's also just using single cycle and like mobile generators and stuff, which is less efficient. But he's, there's also like the flip side, which is like solar power generation is like this, and wind is another like this, different correlate, different. So if you stack both of those, plus you get a big chunk of batteries, plus you have a little bit of gas, it is possible to run it more green. It's just the time scales for that is slow. Right. So people are trying, but, Meta basically said, whatever, don't care about my sustainability pledge, or they'll buy like power. It's called a PPA, power purchasing agreement, where there'll be a massive wind farm or solar farm, like wherever. Oh. And then they'll just pretend like those electrons are being consumed by the data center. But in reality, they're paying for the power here and selling it to the grid, and they're buying power here. Yep. And then another thing is like Microsoft quit on some of their sustainability pledges, right? Elon, he what he did with Memphis is objectively somewhat dirty, but he's also doing it in an area where there's like a bigger natural gas plant right next door and like a sewer or not a sewer, but like a wastewater treatment and a garbage dump nearby, right? And he's obviously made the world a lot more clean than that one data center is going to do, right? So I think like it's fine to some extent, and maybe AGI solves global warming and stuff, right? Whatever it is. This is sort of the attitude that people at the labs have, right? Which is like, yeah, screw it, we'll just use gas, right? Because the race is that important, and if we lose, that's way worse, right?
I should say that I got a chance to visit the Memphis data center.
Oh, wow.
And it's kind of incredible. I mean, I visited with Elon. Just the teams and the rate of innovation there is insane. Because my sense is that, nobody's ever done anything of this scale, and nobody has certainly ever done anything of this scale at the rate that xAI is doing. So they're like figuring out, I mean, and so I was sitting in on all these meetings where they're brainstorming. It's like, it's insane. It's exciting because they're like, they're trying to figure out what the bottlenecks are, how to remove the bottlenecks, how to make sure that, there's just so many really cool things about putting together a data center because, everything has to work. It's the people that do like the sysadmin, the machine learning, all that is the exciting thing, so on. But really, the people that run everything are the folks that know like the low level software and hardware that runs everything, the networking, all of that. And so you have to like make sure you have procedures that test everything. I think they're using Ethernet. I don't know how they're doing the networking, but
they're using Nvidia's Spectrum X Ethernet. There's actually I think, the unsung heroes are the cooling and electrical systems, which are just
exactly.
like glossed over.
Yeah.
But I think like one story that maybe is like exemplifies how insane this stuff is when you're training, right? You're always doing you're running through the model a bunch, right? In the most simplistic terms, running through the model a bunch. And then you're going to exchange everything and synchronize the weights, right? So you'll do a step. This is like a step in model training, right? And every step your loss goes down, hopefully, and it doesn't always. But in the simplest terms, you'll be computing a lot and then you'll exchange, right? The interesting thing is GPU power is most of it. Networking power is some, but it's a lot less. But so while you're computing, your power for your GPUs is here. But then when you're exchanging weights, if you're not able to overlap communications and compute perfectly, there may be a time period where your GPUs are just idle and you're exchanging weights and you're like, hey, the model's updating. So you're exchanging the gradients, you do the model update, and then you start training again. So the power goes, right? And it's super spiky. Yeah. And so funnily enough, right, like this, when you talk about the scale of data center power, right, you can blow stuff up so easily. Yeah. And so Meta actually has accidentally upstreamed something to code in PyTorch where they added an operator. And I kid you not, whoever made this, like I want to hug the guy because it says PyTorch, it's like PyTorch.powerplant no blow up equals 0 or equal 1. And what it does is amazing, right? Yeah. Either, when you're exchanging the weights, the GPU will just compute fake numbers. So the power doesn't spike too much. And so then the power plants don't blow up because the transient spikes like screw stuff up.
Well, that makes sense. I mean, you have to do that kind of thing. You have to make sure they're not idle. Yeah.
And Elon's solution was like, let me throw a bunch of Tesla mega packs and a few other things, right? Like everyone has different solutions, but like Meta's at least was publicly and openly known, which is just like set this operator. And what this operator does is it just makes the GPUs compute nothing so that the power doesn't spike.
But that just tells you how much power you're working with. I mean, it's insane. It's insane.
People should just go to Google, like scale, like what does X watts do, and go through all the scales from 1 watt to a kilowatt to a megawatt. And you stare at that, and you're how high on the list a gigawatt is, and it's mind blowing.
Can you say something about the cooling? So I know Elon's using liquid cooling, I believe, in all cases. That's a new thing, right? Most of them don't use liquid cooling. Is there something interesting to say about the cooling?
Yeah. So air cooling has been the de facto standard. Throw a bunch of metal, heat pipes, etc., and fans, right? And like that's cooled. That's been enough to cool it. People have been dabbling in water cooling. Google's TPUs are water cooled, right? So they've been doing that for a few years. But with GPUs, no one's ever done, and no one's ever done the scale of water cooling that Elon just did, right? Now, next generation Nvidia is for the like highest end GPU, it is mandatory water cooling. You have to water cool it. But Elon did it on this current generation, and that required a lot of stuff, right? If you look at like some of the satellite photos and stuff of the Memphis facility, there's all these external water chillers that are sitting basically. It looks like a semi-truck pod thing. What's it called? The container. But really, those are water chillers, and he has like 90 of those water chillers just sitting outside. 90 different containers, right, with water, that chill the water, bring it back to the data center, and then you distribute it to all the chips, pull all the heat out, and then send it back, right? And this is both a way to cool the chips, but also an efficiency thing. All right, and going back to that like sort of 3-vector thing, right? There is memory bandwidth, flops, and interconnect. The closer the chips are together, the easier it is to do high-speed interconnects, right? And so this is also like a reason why you're going to go water cooling is because you can just put the chips right next to each other and therefore get higher speed connectivity.
I got to ask you, so in one of your recent posts, there's a section called cluster measuring contest. So
there's another word there, but I won't say it,
who's got the biggest now and who's going to have the biggest?
Today, individual largest is Elon, right?
Elon's cluster
in Memphis, 200,000 GPUs, right? Meta has like 128,000, OpenAI has 100,000. Now, to be clear, other companies have more GPUs than Elon. They just don't have them in one place, right? And for training, you want them tightly connected. There's some techniques that people are researching and working on that let you train across multiple regions, but for the most part, you want them all in like one area, right? So you can connect them with high-speed networking. And so, Elon today has 200,000 H100s and 100,000 H100s, 100,000 H200s, right? Meta, OpenAI, and Amazon all have on the scale of 100,000, a little bit less. But this year, people are building much more, right? Anthropic and Amazon are building a cluster of 400,000 Trainium 2, which is Amazon's specific chip, trying to get away from Nvidia, right? Meta and OpenAI have scales for hundreds of thousands, but by next year you'll have like 500,000 to 700,000 GPU clusters, and note those GPUs are much higher power consumption than existing ones, right? Hopper 700 watts, Blackwell goes to 1200 watts, right? So the power per chip is growing and the number of chips is growing, right?
Nuts. You think Elon said he'll get to 1 million. You think that's actually feasible?
I mean, I don't doubt Elon, right? The filings that he has for like, the power plant and the Tesla battery packs, it's clear he has some crazy plans for Memphis. Like permits and stuff is open record, right? But it's not quite clear that, what the timescales are. I just never doubt Elon, right? He's going to surprise us.
So what's the idea with these clusters? If you have 1 million GPUs, what percentage in let's say 2-3 years is used for training, and what percent pre-training, and what percent is used for the actual computation?
So these mega clusters make no sense for inference, right? You could route inference there and just not train. But most of the inference capacity is being, hey, I've got a 30 megawatt data center here, I've got 50 megawatts here, I've got 100 here, whatever. I'll just throw inference in all of those because the mega clusters, right, multi-gigawatt data centers, I want to train there because that's where all of my GPUs are co-located, where I can put them at a super high networking speed connected together, right? Because that's what you need for training. Now, with pre-training, this is the old scale, right? You would increase parameters, you'd increase data, model gets better. That doesn't apply anymore because there's not much more data in the pre-training side, right? Yes, there's video and audio and image that has not been fully taken advantage of, so there's a lot more scaling. But a lot of people have taken transcripts of YouTube videos, and that gets you a lot of the data. It doesn't get you all of the learning value out of the video and image data, but there's still scaling to be done on pre-training. But this post-training world is where all the flops are going to be spent, right? The model's going to play with itself. It's going to self-play. It's going to do verifiable tasks. It's going to do computer use in sandboxes. It might even do like simulated robotics things, right? Like all of these things are going to be environments where compute is spent in quote unquote post-training. But I think it's going to be good. We're gonna drop the post from post-training.
Yeah,
it's going to be pre-training and it's going to be training, I think.
The return of the king.
At some point. Because for the bulk of the last few years, pre-training has dwarfed post-training.
Mm-hmm.
But with these verifiable methods, especially ones that scale really, potentially infinitely, like computer use and robotics, not just math and coding, right, where you can verify what's happening, those infinitely verifiable tasks, it seems you can spend as much compute as you want on them.
Especially at the context length increase, because at the end of pre-training is when you increase the context length for these models. And we've talked earlier in the conversation about how the context length, when you have a long input, is much easier to manage than output. And a lot of these post-training and reasoning techniques rely on a ton of sampling, and it's becoming increasingly long context. So there's just your compute efficiency goes down. I think flops is the standard for how you measure it, but with RL, and you have to do all these things where you move your weights around in a different way than at pre-training and just generation, it's going to become less efficient, and flops is going to be less of a useful term. And then as the infrastructure gets better, it's probably going to go back to flops.
So all of the things we've been talking about is most likely going to be Nvidia, right? Is there any competitors?
Google, I kind of ignored them.
What's the story with TPU? What's the story with TPU? What's the
TPU is awesome, right? It's great. Google they're a bit more tepid on building data centers for some reason. They're building big data centers. Don't get me wrong, and they actually have the biggest cluster. I was talking about Nvidia clusters. They actually have the biggest cluster. Period. But the way they do it is very interesting, right? They have two sort of data center super regions, right? In that the data center isn't physically all of the GPUs aren't physically on one site, but they're 30 miles from each other. Or not GPUs, TPUs, right? They have in Iowa and Nebraska, they have 4 data centers that are just right next to each other.
Why doesn't Google flex its cluster size?
Go to multi-data center training. There's good images in there, so I'll show you what I mean. It's just SemiAnalysis multi-data center. So this is so this is an image of what a standard Google data center looks like. By the way, their data centers look very different than anyone else's data centers.
What are we looking at here?
So these are, so if you see this image, right, in the center, there are these big rectangular boxes, right? Those are where the actual chips are kept. And then if you scroll down a little bit further, you can see there's these water pipes, there's these chiller cooling towers in the top, and a bunch of diesel generators. The diesel generators are backup power. The data center itself is look physically smaller than the water chillers, right? So the chips are actually easier to keep together, but then cooling all the water for the water cooling is very difficult, right? So Google has a very advanced infrastructure that no one else has for the TPU. And what they do is they've like stamped a bunch of these data centers out in a few regions, right? So if you go a little bit further down, this is a Microsoft. This is in Arizona. This is where GPT-5 quote unquote will be trained.
If it doesn't exist already.
Yeah, if it doesn't exist already. But each of these data centers, right? I've shown a couple images of them. They're like really closely co-located in the same region, right? Nebraska, Iowa, and then they also have a similar one in Ohio complex, right? And so these data centers are really close to each other. And what they've done is they've connected them super high bandwidth with fiber. And so these are just a bunch of data centers. And the point here is that Google has a very advanced infrastructure, very tightly connected in a small region. So Elon will always say have the biggest cluster fully connected, right? Because it's all in one building, right? And he's completely right on that, right? Google has the biggest cluster, but you have to spread over 3 sites, and by a significant margin, but you have to go across multiple sites.
Why doesn't Google compete with Nvidia? Why don't they sell TPUs?
I think there's a couple problems with it. It's like, one, TPU has been a form of allowing search to be really freaking cheap and build models for that, right? And so like a big chunk of the search GPU purchases or TPU purchases, or big chunk of Google's purchases and usage, all of it is for internal workloads, right? Whether it be search, now Gemini, right? YouTube, all these different applications that they have, ads. These are where all their TPUs are being spent, and that's what they're hyper focused on, right? And so there's certain like aspects of the architecture that are optimized for their use case that are not optimized elsewhere, right? One simple one is like they've open sourced the Gemma model, and they called it Gemma 7B, right? But then it's actually 8 billion parameters because the vocabulary is so large. And the reason they made the vocabulary so large is because TPU's like matrix multiply unit is massive, because that's what they've like sort of optimized for. And so they decided, oh, well, I'll just make the vocabulary large too, even though it makes no sense to do so on such a small model, because that fits on their hardware. So Gemma doesn't run as efficiently on a GPU as a Llama does, right? But vice versa, Llama doesn't run as efficiently on a TPU as a Gemma does, right? And it's so like there's like certain like aspects of like hardware software co-design. So all their search models are their ranking and recommendation models, all these different models that are AI, but not like Gen AI, right, have been hyper optimized with TPUs forever. The software stack is super optimized, but all of this software stack has not been released publicly at all, right? Very small portions of it, JAX and xLA have been, but like the experience when you're inside of Google and you're training on TPUs as a researcher, you don't need to know anything about the hardware in many cases, right? Like it's like pretty beautiful. But as soon as you step outside,
they all go. A lot of them go back. They leave Google and then they go back.
Yeah, they're like they leave and they start a company because they have all these amazing research ideas, and they're like, wait, infrastructure is hard, software is hard, and this is on GPUs. Or if they try to use TPUs, same thing, because they don't have access to all this code. And so it's like, how do you convince a company whose golden goose is search, where they're making hundreds of billions of dollars from, to start selling GPU or TPUs, which they used to only buy a couple billion of, I think in 2023 they bought like a couple billion. And now they're buying like $10 billion to $15 billion worth. But how do you convince them that they should just buy like twice as many and figure out how to sell them and make $30 billion? Like, who cares about making $30 billion?
Won't that $30 billion exceed actually the search profit eventually?
Oh, I mean, like, you're always going to make more money on services than
always.
I mean, like, yeah, like, like, to be clear, like today people are spending a lot more on hardware than they are the services, right? Because the hardware front runs the service spend. Sure. But like,
you're investing. Yeah.
If there's no revenue for AI stuff, or not enough revenue, then obviously like it's going to blow up, right? People won't continue to spend on GPUs forever. And Nvidia is trying to move up the stack with like software that they're trying to sell and license and stuff, right? But Google has never had that like DNA of like, this is a product we should sell, right? They don't. The Google Cloud which is a separate organization from the TPU team, which is a separate organization from the DeepMind team, which is a separate organization from the search team, right? There's a lot of bureaucracy.
Wait, here. Google Cloud is a separate team than the TPU team?
Technically, TPU sits under infrastructure, which sits under Google Cloud, but like Google Cloud, like for like renting stuff, and TPU architecture are very different goals, right? In hardware. And software, like all of this, right? Like the JAX XLA teams do not serve Google's customers externally, whereas NVIDIA's various CUDA teams for like things like Nickel serve external customers, right? The internal teams like JAX and XLA and stuff, they more so serve DeepMind and search, right? And so their customer is different. They're not building a product for them.
Do you understand why AWS keeps winning versus Azure for cloud? versus Google Cloud.
Yeah,
Google Cloud is tiny, isn't it, relative to AWS?
Google Cloud is third. Yeah. Microsoft is the second biggest, but Amazon is the biggest, right?
Yeah.
And Microsoft deceptively sort of includes like Microsoft Office 365 and things like that, like some of these enterprise-wide licenses. So in reality, the gulf is even larger. Microsoft is still second, though, right? Amazon is way bigger. Why? Because using AWS is better and easier, and in many cases, it's cheaper. And it's first. Yeah.
It was first.
Yeah, but there's a lot of things that are first. That
it's easier. It's harder to switch than it is to.
But AWS
because
is their core.
There's big fees for switching too.
AWS generates over 80% of Amazon's profit. I think over 90%. Right?
That's insane.
The distribution centers are just like, one day we'll decide to make money from this, but they haven't yet, right? Like they make tiny little profit from it.
Yeah, one day Amazon Prime will triple in price.
You would think they would improve AWS interface because it's like horrible. It's like clunky. But everybody is.
I don't. Yeah, one would think.
I think actually Google's interface is sometimes nice, but it's also like they don't care about anyone besides their top customers.
Yeah, exactly.
And like their customer service sucks, and like they have a lot less like.
I mean, all these companies they optimize for the big customers. Yeah, it's supposed to be for business.
And Amazon has always optimized for the small customer too, though, right? Like obviously they optimize a lot for the big customer, but like when they started, they just would go to like random Bay Area things and give out credits. Right. And then they like, or just put in your credit card and use us. Right. Like it's back in the early days. So they've always, the business has grown with them. Right. And burgeoned. So like, why does Amazon, like, why is Snowflake all over Amazon? Because Snowflake in the beginning, when Amazon didn't care about them, was still using Amazon. Right. And then of course, one day Snowflake and Amazon has a super huge partnership. But like, this is the case, like Amazon's user experience and quality is better. Also, a lot of the silicon they've engineered makes them have a lower cost structure in traditional cloud storage, CPU, networking, that kind of stuff than, in databases, right? Like, I think like 4 of Amazon's top 5 revenue products, margin products, are like gross profit products, are all database related products, like Redshift and like all these things, right? Like, so Amazon has a very like good silicon to a user experience, like entire pipeline with AWS. I think Google, their silicon teams, yeah, they have awesome silicon internally, TPU, the YouTube chip, some of these other chips that they've made, and the problem is they're not serving external customers; they're serving internal customers, right?
Nvidia's entire culture is designed from the bottom up to do this. There's this recent book, The Nvidia Way by Take Him, that details this and how they look for future opportunities and ready their CUDA software libraries to make it so that new applications of high performance computing can very rapidly be evolved on CUDA and Nvidia chips. And that is entirely different than Google as a services business.
Yeah, I mean, Nvidia, it should be said, is a truly special company. Like, I mean, they're the culture, everything, they're really optimized for that kind of thing. Speaking of which, is there somebody that can even challenge Nvidia hardware-wise? Intel, AMD?
I really don't think so. We went through a very long process of working with AMD on training on their GPUs and inference and stuff, and they're decent. Their hardware is better in many ways than Nvidia's. The problem is their software is really bad, and I think they're getting better, right? They're getting better faster, but the gulf is so large, and like they don't spend enough resources on it, or haven't historically, right? Maybe they're changing their tune now, but for multiple months we were submitting the most bugs, right? Like us, SemiAnalysis, right? Like, what the fuck? Like, why are we submitting the most bugs, right? Because they only cared about their like biggest customers, and so they'd ship them a private image, blah blah blah, and it's like, okay, but like, I am just using PyTorch, and I want to use the publicly available libraries, and like, you don't care about that, right? So they're getting better, but like, I think AMD is not possible. Intel's obviously in dire straits right now, and needs to be saved somehow. Very important for national security, for American technology dominance.
Can you explain the obviously? So why are they in dire straits?
Going back to earlier, only 3 companies can R&D, right? Yeah. Taiwan, Hsinchu, Samsung, Pyongyang, and then Intel, Hillsboro. Samsung's doing horribly, Intel's doing horribly. We could be in a world where there's only one company that can do R&D, and that one company already manufactures most of the chips. They've been gaining market share anyways, but like that's a critical thing, right? So what happens to Taiwan means the rest of the world's semiconductor industry, and therefore tech, relies on Taiwan, right? And that's obviously precarious. As far as like Intel, they've been slowly, steadily declining. They were on top of servers and PCs, but now Apple's done the M1, and Nvidia's releasing a PC chip, and Qualcomm's releasing a PC chip, and in servers, hyperscalers are all making their own ARM-based server chips, and Intel has no AI silicon like wins, right? They have very small wins. and they never got into mobile because they said no to the iPhone, and like all these things have compounded, and they've lost their process technology leadership, right? They were ahead for 20 years and now they're behind by at least a couple years, right? And they're trying to catch back up, and we'll see if like their 18A, 14A strategy works out where they try and leapfrog TSMC. But like, and Intel's just like losing tons of money anyways, right? And they just fired their CEO, even though the CEO was the only person who understood the company well, right? We'll see. He was not the best, but he was pretty good, relatively technical guy.
Where does Intel make most of its money? The CPUs still, right?
PCs and data center CPUs, yeah. But data center CPUs are all going cloud, and Amazon, Microsoft, Google are making ARM-based CPUs. And then PC side, AMD's gained market share. Nvidia's launching a chip. That's not going to be a success, right? MediaTek, Qualcomm have launched chips. Apple's doing well, right? Like they could get squeezed a little bit in PC, although PC generally, I imagine, will just stick Intel mostly for Windows side.